Hi everyone, welcome. In this talk, we will be looking at the lifetime of a Gluster client process. We will be using netstat to see how the connections happen and what happens when a disconnect happens with glusterd or a brick. So let me share my screen and we will have a setup to go over. Sharing the screen now. Okay. So let me clear the screen and bring back the state to a clean one. What I have here is a setup where I have one client and two servers. The one on the top is a client and the two at the bottom are servers. I will erase all the working directory of glusterd so that we have a clean setup here. Just checking if there are any Gluster processes running. Okay, no Gluster processes running. Let me clean up the bricks and we will. Okay. Let us do a cluster peer probe from the one on the left to the one on the right. Forgot glusterd seems to be down. Running glusterd on both ends. Okay, good. So Gluster peer status here shows 1. Gluster peer status here shows 1. Okay. So the talk is about Gluster client process. When you install Gluster, you will have a Gluster FSD binary which is installed as part of it. So let us see if we can get that. Okay, I'll just show the binary here. Okay, it is in user SPN Gluster FSD. This is the binary which gets installed when you install Gluster. It can take many forms. That's the same binary which actually runs as glusterd, Gluster brick process, and also as the Gluster client process. Today we'll be only looking at how it becomes the client. If you are using a GF API based client, then the model is a little different. We will not be looking at that now. So we have to create a volume first. Let us create a volume. Volume is created. Let us start the volume now. Volume is started. I had mounted it before, so I'll unmount it. Okay. I've now mounted the volume. So what happens when I mount a volume, a Gluster volume? Let us look through netstat. Here, what we can see is that there is a GlusterFS process running. So let us look at all the arguments which were given to this particular process. So we have called user SPN GlusterFS, but I just told you that we use user SPN GlusterFSD. So how does that work? Let us debug that a little. So as you can see here, a GlusterFS binary here, the file is just a link to the GlusterFSD. This is the reason I told you that GlusterFSD is the real binary. Okay, so this part is sorted. We call GlusterFS and then we provide a volfile server to it and we provide a volfile ID to it and the mount point. Hey, but did I not just call mount -p GlusterFS here? Yes. So the mount -p GlusterFS is a call to a GlusterFS script that resides in user SBIN mount, user SBIN mount.glusterfs. It transforms the argument given next to it into this particular command line, which you are seeing here. So the shell script there takes in the arguments and then calls user SBIN GlusterFS with the relevant arguments. So what this actually meant is that we said, hey, I want you to fetch the vol file for my volume, which is volume 1. And the vol file has to be fetched from the glusterd, which is running at this particular IP, and then mount it here. Okay, so that explains why I see a netstat line, which is here, the third line. We opened a port with this binary, and then we contacted glusterd on 24007 port at the given IP. That is done. Why do we have two more lines here? If you see the Gluster volume create command that I did here, I gave two bricks, brick 1 and brick 2. And if you notice, there seems to be some symmetry to it. So here, the process is connecting to server on 15 and port number is 49152. Again, it is connecting from a different client port to the other server and connecting to 49152. Okay, let us see what cluster volume info shows here. Cluster volume status will show us the PID and also the port that the volume is working on. So as you can see from both the outputs here, one of the bricks is on server 15 and it is listening on port 49152. The other brick is on server 16 and it is listening on port 49152. That's the reason you see that the GlusterFS client process is connected to one port each on these two machines. So this is a very common question asked by many folks who look at Gluster for the first time. They are not sure if all the bricks are contacted by Gluster client process at the same time, or is it a failover kind of a thing. So the answer for that question is all the bricks are always connected. A Gluster client process will be connected to all the bricks of the volume at all given point of time, as long as the network is available for it. Okay, so the two last things I have before we finish the talk is what happens when a brick goes down and what happens when glusterd goes down. So let us go ahead and kill the brick on this particular machine, which is 1512. Okay, so the brick is killed. Let us see what happens to the netstat output now. Hey, okay, we have one line missing now. Let us see if Gluster is trying to do any reconnections of any sort. Yes, it is. So as you can see, server 15 is still up and our connection to both glusterd and the brick on server 15 is up and fine. The other one is being retried and we are not able to get it because the brick is not running. What happens when I do a Gluster volume start, volume 1 force? This will restart all the bricks. So that should immediately get us back to our connection on server 16 and we have it back. So because we did a restart here, if I do a volume status, you can see that the volume status shows a new port as the listening port for this new brick, and that's also reflected here in the netstat output. So that is what happened when a brick goes down. Whenever a client and a brick lose their connection, client will again try to reconnect to the brick. The process is not straightforward. It does not again send a connect to the same port on the same IP. Rather, it will contact glusterd on that machine, ask for the new port, because glusterd is the only source of truth for what is the port for a particular brick. As you can see here, glusterd had changed the port of this brick when it did the restart of the brick. And glusterd sends back 49153 as the port number for the new brick, and then the client connects to the brick. So whenever a disconnection between a client and brick happens, it's always a two-step process. You ask the glusterd first for the port number, and then you connect to the brick on that particular port number. Okay, so this is done. Last part. What happens when glusterd goes down? So as I told you, we contacted glusterd to get the volfile, and this third line in the top screen represents that connection. So if I kill glusterd here on this particular machine, that connection is lost. Okay. At this point of time, can I still use my mount? Yes, you can, because glusterd is only a management daemon. You don't really need glusterd to be working for your IO path to go through. So if I do a touch of a file on the mount point, it works fine. We can even verify that it's available on both the. I have created distribute only volume, so it will be available on either of these bricks. It's not on brick 1, so it should be on the second brick. There it is. So the file exists and the IO seems to be working fine. There is no problem with the IO. Then why do you need a persistent connection to glusterd? Well, you need a persistent connection to glusterd because only glusterd knows about changes which are happening to a volume. Say I do a Gluster volume set effect of for volume 1. Now this edits. Okay. So this edits attribute of a volume which only glusterd is aware of. And if I go back to looking at the netstat output here, we are not connected to glusterd at all. So this will now lead to a problem where the stats prefetch xlator is still loaded on this particular client. How do I verify this? I can probably check it by meta. Let us go into meta here and let us see what the active graph holds. And stat prefetch is called MD cache here. And as you can see here, there is an MD cache folder visible. That means any change which happens to a Gluster volume won't get reflected if the mount is not connected to a Gluster process. Let us unmount and then mount the same volume again. Okay, that was because the Gluster is still down. Let me restart Gluster here. Okay, and let us check what the graph shows now. As you can see, there is no empty cache here because now, because we did a remount, we got the latest vol file from the new cluster D, and the latest fault file said there is no empty cache. This is not a bug. Yes, I understand what you're thinking. You're thinking, hey, if that means no updates are sent to the mount when the cluster D is down, then it's a risk. Yes, it is a risk. And that's why we have the option of backup vol file server, where you can provide all the vol file servers at the same time during the mount, so that one connection to cluster D going down does not cause any problem. That's it for now. Thank you.